We started the design process by going through problem definition. Through this, we came up with functions, objectives, and constraints for our design that allowed us a deeper understanding of the problem at hand. Our function is that any feasible design must get food from the launch zone to the landing zone without any contact with the canyon. We then found that our design has many constraints, including the following that are listed here. And finally, we came up with the following objectives, prioritizing accuracy, low cost, low carbon emissions, and aesthetics.
Through extensive research and ideating, our group came up with a few possible solutions. Our first idea was a spring-loaded cannon. This wasn't our best solution, so we came up with a few more. The next idea we had was to make a zipline that used motors to transport the egg across the canyon. Through some very hard calculations, we realized it didn't fit our constraints, so we had to keep thinking. Our next idea was a cart on a ramp to go down and jump over the canyon, and this wasn't possible, we thought. The final idea we had was to use a catapult to launch the egg across the canyon, and we finally came up with our last idea, which was to just get rid of the catapult arm and turn the idea into a short slingshot, utilizing the most energy possible.
We then created a weighted matrix with the other three choices, considering accuracy, precision, cost, emissions, and aesthetics. The results of this weighted matrix showed that the catapult had the highest score, so we chose this design. Our original catapult design was intended to have a 750mm length PVC launch arm. However, once we began testing, we realized this was too heavy and wouldn't launch the egg far enough. We then modified our design by removing the launch arm and transforming it into a slingshot with a plastic launch container. This modification allowed the ball to reach the specified distance. To protect the egg, we enclosed it in a styrofoam ball, then tied a string between the ball and the base of the launcher so that it would not travel too far.
The slingshot was relatively easy to put together. It only used simple carpentry techniques. The real issue we had was inadequate drills. We first began by building the base and then inserting 2 eye hooks. We then inserted a pin to act as the trigger mechanism for our slingshot. Next, we added the 2 upright arms and 2 more eye hooks to act as attachment points for the bucket of the slingshot and the elastics. After that, we added 4 angled pieces to act as supports so the arms wouldn't bend. Lastly, we added the bucket and 4 legs to add more potential energy to our design.
Here's a quick video of us setting up our trigger mechanism. And lastly, this is our competition video where we launched our styrofoam ball. We unfortunately didn't make it to the landing zone.